Hello everybody. So here's my, at least at the time I'm making these videos, this is my second video on linear programming, okay? And so far I've showed you something like this, where I described linear programming as a type of problem where we want to maximize or minimize the value of some objective function, and it'll be subject to constraints. The constraints will be inequalities, and the way that the problem works is that we graph the inequalities. We'll notice that there are corner points if we graph that region, and the maximum or minimum of the objective function will have to be at one of the corner points. Okay? The broader problem is that we want to figure out, of all the points in this region satisfied by the inequalities, which point gives you the largest value in the objective function. But what's easy about it is that that point has to be one of the corner points. So all we have to do is graph the region bounded by the inequalities, okay? Identify the corner points, and then check which corner point gives you either the maximum or minimum in the objective function, whichever you're trying to find. That's the procedure. Now, where that might get more difficult is if we have some kind of word problem, because it won't be of tremendous interest if we just try to maximize some nameless function subject to these constraints with no description. The real type of problem that I want everybody to get a feel for is if some situation is described to us, that we can identify all those parts, okay? So here's the situation that we're going to have to read through, and it turns out it will be a linear programming problem. We're going to try to maximize or minimize something. It will be subject to constraints. The constraints will be inequalities. We'll check the corner points and see which one gives us our answer, okay? It'll be harder to do that if we have to read this and figure out what all that is. But that's what I want to go through with you. And I'll break it down into steps, and I'll go through every problem I show you like this. I'll use the same sequence of steps, okay? But let's read it first. We'll get a feel for what we're working with. We have an auto mechanic. It takes 2 hours to replace shocks and 2 hours to replace brakes. This mechanic works no more than 42 hours a week. The mechanic will also complete at least 4 shock replacements and 6 brake replacements in a week. Mechanic charges $400 for labor in replacing shocks and $200 in labor for replacing brakes. And the question is that we could have a variety of assortment of jobs. Like, it's like what's open here is, well, how many shock replacements can this mechanic do, and how many brake replacements can the mechanic do? But of all those possible assortments, which one will maximize his income? Okay, so that's the basic problem. Now, see, I just read this real quick, and I didn't really worry about any statement in it. I just wanted to get a feel for what's happening. Okay, all right. Our first step beyond that is to make sure that we understand what we read and try to get some setup for the problem that looks kind of like this, that there's something we want to maximize, some equation, and then there will be these constraints that are inequalities. Okay, so I'm gonna try to read this with that thinking in mind. Okay, now the thing I want to maximize, I thought that was pretty clear about it. It says how many of each type of jobs should the mechanic complete each week to maximize his income? So the thing I want to maximize is the weekly income, okay? Factors related to that are that this mechanic charges $400 for labor and replacing shocks and $200 for replacing brakes. Okay, so that's the thing I want to maximize. I didn't write it as an equation yet because I'm not wanting to get too far ahead. Okay, I'm still at the point where I'm reading it and I'm making sure I understand what I read. So that's where I recommend you start. Now, as far as the constraints, now remember the constraints will be inequalities of some kind. Inequalities have greater than or equal to and less than or equal to somehow. Okay, now I saw in here when I read it that it said the mechanic works no more than 42 hours per week. That is an inequality, right? no more than. That's going to mean less than or equal to, okay? So I put that in red there. I wanted that to stand out about that sentence because that identifies it as one of the constraints. Some other statements I read is that he completes at least 4 shock replacements and at least 6 brake replacements. Okay, so that at least also tells me that we're dealing with inequality. That sounds like greater than or equal to. Okay, so those are the statements I read that identify with constraints. Okay, now one last thing. Ultimately, I am going to get equations and inequalities out of this. So far, I'm just verbal. I'm just reading this and I'm writing down some stuff that I read and dividing it into the parts of the problem. Now, in order to go to the stage of this where we have equations and inequalities, I need an unknown. I need variables. I need x and y. So I'm going to let x be the number of shock replacements the mechanic does per week, and I'm going to let y be the number of brake replacements the mechanic does per week. So my next step then is that now that I've read this and I think I've understood it, I've written everything down as it should be divided into the problem. My next step is to write all of that as equations and inequalities, okay? All right, now, so here's what is starting to look more like our initial linear programming problem, okay? I want to maximize weekly income. So think about it. If this mechanic gets $400 per shock replacement and $200 per brake replacement, and X is the number of shock replacements per week, and Y is the number of brake replacements per week, then here's my equation to calculate weekly income. 400 times X plus 200 times Y. Okay? All right, so I've got that part. Now about the constraints, what I need to do next is take each of these statements and turn it into an inequality. So if it says that this particular mechanic can work no more than 42 hours per week, okay, how do I turn that into an inequality? Well, so let's see. It says here that this mechanic spends 2 hours when he replaces shocks and 2 hours when he replaces brakes. So, if in addition to that, X is the number of shock replacements per week and Y is the number of brake replacements per week, and they each take 2 hours, then I need 2X plus 2Y to be less than or equal to 42. So, look at that right there. 2X plus 2Y less than or equal to 42 is equivalent to the verbal statement that the mechanic will work no more than 42 hours per week. Okay? This is how we could calculate the number of hours the mechanic works. That needs to be less than or equal to 42. That's like saying no more than 42. Okay? So less than or equal to 42. So there goes that first one. What about the next one? Complete at least 4 shock replacements. The mechanic will need to complete at least 4 shock replacements. Well, X is the number of shock replacements. So we'll get X is greater than or equal to 4. And it also said complete at least 6 brake replacements. Well, Y is the number of brake replacements. Then we get Y is greater than or equal to 6. Okay, so there's all of our equations and inequalities. Now it looks like this first problem. Okay, all right. I got my equation, I got my inequalities, and at this point, let's remember how this works. If you want to maximize this function, the number you get out of that function, based on X and based on Y, that will be at one of the corner points of this region. Okay, so that brings us to the second step. Step 2, I need to graph the feasible region and solve for the corner points. So the feasible region is the region outlined by these inequalities. Okay. Now this is one of those things I'm not going to focus on a whole lot in the video because I've covered it elsewhere. In other videos that I've posted to lead up to this, I've covered how do you graph a line, How do you figure out where two lines intersect? How do you graph a inequality? I've done all that. So I didn't want that to be the focus of this. So if I'm going to graph these inequalities, it looks like this region in blue. Okay, this triangular region of 3 corner points, A, B, and C. Okay, I'll have to solve for them, but as I said, that's been covered in other videos. All right, one thing I will talk about is this one, 2x plus 2y is less than or equal to 42. So real quick, suppose that I have 2x plus 2y is less than or equal to 42, and I want to graph that somehow. That's not really in a form that subjects itself to be graphed as it is. So I want to solve it for y. So notice I get 2y is less than or equal to 42 minus 2x. And then I'll divide by 2. And I get y is less than or equal to 21 minus x. Okay? Now, to graph that, y is less than or equal to 21 minus x, I start by graphing the line 21 minus x. Y is 21 minus x, which is this line with this downward slope right here. Okay? And for it to say y is less than or equal to 21 minus x means all the points that are under it. So notice the shading only exists under this line. So that's how it came about. That's how this picture came about. So what you're looking at when you graph the feasible region is all the points under this line, right of this one, and above this one. Okay? So here you're looking at it, all the points under 21 minus x, right of x minus 4, and above y equals 6. Or sorry, x equals 4, right of x equals 4, and above y equals 6. Okay, now when we solve for the corner points, we find A is 4 for x, 6 for y, B is 4 for x, 17 for y, and C is 15 for x and 6 for y. Now, if what you want is to figure out the maximum value of I, the maximum income, that number has to be at one of the corners. So one of these is going to give me whatever the maximum is. So that brings us to step 3. Test each of the corner points in the income function to determine the maximum. Now the income function was I income, weekly income is 400x plus 200y. Point A was 4 for x, 6 for y. Point B, 4 for x, 17 for y. And point C, 15 for x and 6 for y. Plugging each one of those into this gives me 2,800, 5,000, and 7,200. 7,200 is our maximum. Okay, the maximum is one of these. So whichever one is the biggest is going to be the answer. All right, so that's step 3. Okay, step 4 is just give some statement of your answer. So I would say the maximum possible weekly income is $7,200. The way you'll get that in this scenario is from 15 shock replacements and 6 brake replacements. Okay, so that's how I would state the answer from my work in the previous step. You'll see that up here in this screenshot from MyMathLab, that's how the answer is input for that particular question.